Hello, everyone. My name is Katie. I'm a director at large with SEDS-Canada, and I'm really happy to bring this panel to you today. We have 5 teams from the Canadian CubeSat project who are going to talk about what their teams do and their satellites and how those satellites are really beneficial for Canada. So we're really happy to have everyone here for World Space Week, and we're just going to jump in with introductions. So, Paula, would you like to go first?
Yeah, for sure. Hi everyone. My name is Paula Boska. I'm in my 4th year of the Integrated Science program at McMaster University, specializing in physics. And I'm on the McMaster Nudos team, building a CubeSat to detect radiation in space.
Awesome. What about Alexis? Do you want to go next?
Sure, yeah. My name is Alexis, and I'm a PhD student at Western University. I'm in the electrical and computer engineering department, and I'm the head of like all things software on this mission. So like onboard computers, flight software, and mission control software. And our CubeSat takes VR images from space.
Very cool. Alex?
Hi guys, I'm Alex DiTomaso. I'm the mechanical systems project manager for the Violet CubeSat based out of the University of New Brunswick. And I'm working on my master's in mechanical engineering.
Awesome. Lavente?
Hi everyone, my name is Lavent Bautista. I am in my 2nd year of electrical engineering, Master of Applied Science at UVIC. I lead the telemetry tracking and commands sub-team of the OrcaSat project, and yeah, we are building a 2U CubeSat. We are based out of Victoria with a partnership led by the University of Victoria and joined by the University of British Columbia. And yeah, looking forward to talking with you guys today.
Awesome. And last but not least, Patrick.
Oh, hi there. My name is Patrick. I'm a technician at the Aurora Research Institute, which is the research section of Aurora College in the Northwest Territories. And I'm here representing the Aurora Sat-1 design team, which is part of the Northern Spirit Consortium. So that's University of Alberta, Yukon University, my apologies, and Aurora College all working together to participate with 3 satellites in the Canadian CubeSat project.
Awesome. So it sounds like you guys are all doing really cool but different things. So it will be fun to find out more. For anyone tuning in on the YouTube Live, feel free to ask comments and we will answer them here on Zoom when we get a chance. So first of all, for anyone who doesn't know, what is the Canadian CubeSat project?
So I'll just jump in. The Canadian CubeSat project is this really cool project run by the Canadian Space Agency, where they are providing funding and expert sort of advice and feedback to universities all across Canada in building and launching a CubeSat, which is a small satellite approximately the size of a loaf of bread, into space.
Very cool. So we all know that you're part of the Canadian CubeSat project, but I was wondering if each of you could tell us a little bit more about your project and what you're hoping to accomplish with your satellite. So I'll start with Alexis.
Sure, yeah. So on a very high level, what our CubeSat is supposed to do is to take VR images, or essentially 360-degree images from space. And right now, we're also applying for a request for deviation so that we can turn on the cameras as the CubeSat is launched. So if you could imagine, like you put on your VR headset, and then you just look around and then you see, oh, that's the ISS over there. And then you look down, oh, there's Earth. And then you look in a different direction, or there's the moon over there. And so it's that kind of payload where it's mostly for an outreach purpose, like making, space, I guess, more, close in that you can actually feel what it's like to be a CubeSat, I guess. So that's what the CubeSat is supposed to do. And so who is on our team? So this whole CubeSat project is run by teams across multiple different departments and different, educational levels. So we've got undergraduate teams or undergraduate capstone teams working on a few subsystems. we've got also graduate students as serving as leads for some of these subsystems. So for example, for myself, we have like a few undergraduate students working on like on the onboard computer, on the flight software, and the mission control software. And same goes for other subsystems where a graduate student leads the subsystem, and then we've got a set of undergraduate students working like for them or on it. And in that way, we have, I guess, more or we spread out the experience to more people. And so every year we switch out like, undergraduate teams, because, you know, as people graduate, we switch out more teams or more students come in. And so like, a lot more people get to have the experience of designing and building a CubeSat.
Awesome. Who gets to see this VR?
So the images are supposed to be available to the public, and so anyone would have access to the VR images.
Amazing. It'll be cool to be able to see space through your CubeSat.
Yeah.
Alex, why don't you go next and tell us what you guys are up to?
Sure. So Violet is a 2U dual payload CubeSat. It has as I said, two payloads. Its primary mission is to investigate space weather in the air glow layer, the uppermost point of our atmosphere. So the first payload is GRIPS, the GNSS receiver for ionospheric and position studies. And GRIPS will be gathering measurements from 4 satellite constellations: GPS, GLONASS, Galileo, and Beidou. And it'll provide insight into the behavior of the Earth's ionosphere due to space weather. And the other payload is SASE, the Spectral Air Glow Structure Imager. And it'll be imaging the oxygen red line from about 80 to 330 kilometers. And we're basically trying to investigate how the air glow layer evolves over time, which is dependent on gravity waves, local chemistry, and atmospheric dynamics. Yeah, and our team's made up of, you know, similarly to all the other CubeSat teams, we have a lot of undergraduates that kind of do their capstone or senior design projects over a year, and that helps us out a lot, gives us a lot of stuff to work with. And then you have more of the graduate students that are working more in the team lead and project management roles. And then on top of that, we have the principal investigators and supervisors that are usually professors. Yeah.
Cool. Why did you guys think that to put 2 different payloads into one like very small satellite? They're already quite small, right?
Yeah, for sure. And it's definitely going to cause us some thermal problems down the road, but I'll leave that for discussion for another day. But yeah, we have a lot of expertise as far as GNSS goes. One of our supervisors has worked with NASA and the CSA in the past and has a lot of experience with that. So it's kind of part of our, I guess, when we submitted our proposal for the project, that as well. And I think having both makes it a very good approach to get that science data.
Makes sense. So jumping out west, Lavent. What are you up to over at UVIC?
All right, so we are also building a 2U CubeSat, and just like Alex was saying, and the way you should imagine this in terms of size and shape and whatnot, it's roughly the size of a carton of milk. So to actually house everything inside of that, what you need to fly a satellite, that is quite a small space. The background of our team is the Canadian Satellite Design Challenge. So both the University of Victoria and the University of British Columbia has an undergraduate team who has been competing in these challenges offered by a nonprofit in Canada for quite a few years now. And for that, we used to build also CubeSats of various sizes and missions, and then have them reviewed in design reviews, and I learned about satellite development that way. And when the Canadian CubeSat project came about, then UBC and UVIC actually teamed up to create the partnership, which is working on our CubeSat now. This CubeSat is called OrcaSat, and the main goal is just student training. So we want to involve as many people as possible in a real life hands-on aerospace project, which will prepare them for a career in the aerospace industry in Canada or elsewhere. And then the secondary goal, because you kind of need an actual mission to build a CubeSat around, is you can think about it taking the twinkle out of the stars. So between the surface of the Earth and space, there is the Earth's atmosphere, and astronomers on the ground trying to use telescopes to look through this. And this atmosphere actually distorts their measurements. So what we are actually doing is putting a light source on board of our CubeSat, and we are putting that up in low Earth orbit. And when the CubeSat flies over ground-based optical observatory, it turns on a light source which is calibrated, and this light source is measured by the observatory on the ground. And the brightness of the light source is also measured on board of the spacecraft, which then we send down to the ground via radio link, and then that way the astronomers can back calibrate their measurements and get a better understanding about our universe through that. And it's basically just removing the effect of the atmosphere from these measurements. And yeah, so that's the basic idea.
Cool. So you're basically making glasses that make the fuzzy images much clearer on the ground for astronomers, right?
Yes, sort of. I guess something to mention about this, that this doesn't happen in real time. So it's more like they take measurements which are less accurate than what they could be. And then certain amount of time later, they receive reference data from our spacecraft, which has to go through us and then sent to them. And then they can back calibrate the data and obtain more accurate measurements. And at the end of the day, like, these are measurement of light brightness. So don't actually imagine this as like images or maybe those pretty photos what you see on astronomy picture of the day or that sort of stuff. It's strictly a scientific mission where you measure the brightness of point sources of light in a process which is called photometry.
Awesome. Okay, hopping up north, Patrick, why don't you tell us what you've got going on over there at AuroraSat?
Sure. Yeah, I suppose we're in quite an interesting position. So we're also targeting a 2U satellite, but through this sort of partnership with Alberta and Yukon, as I mentioned earlier. So our sort of high-level goals are actually to operate 4 missions. So there's one shared mission that all 3 satellites in our consortium will contribute to. And then our AuroraSat itself will have sort of 3 missions that we've targeted at language and art-based outreach. So we're one of the really nice features of the CCP is that there's involvement from every province and territory. And so we're trying to ride with that as much as possible. And what I have, if I get the sides right, yeah, I put a little render here of what we're hoping to actually contribute from the territory. So our little payload there is only one aspect of the larger satellite bus that's being that we're getting assistance from the University of Alberta in assembling, but we're hoping to do that inside the territory and then sort of pack it up nicely and ship it off so that we've really contributed something from where we're living. Our team is also kind of unique. So Aurora College has a very small student population. So the majority of our team is actually high school students who are very interested and working on the project. So quite a lot of success through Canada Science Fair. Having students do projects related to CubeSat and using them as their science fair projects. So that's been a lot of fun. Yeah, I think that's kind of what we're up to.
It's great that you guys are getting like students involved so young. I think that's really amazing. Could you tell me a tiny bit more about what kind of outreach you're hoping to do with art from space?
Sure, yeah. So I think in terms of visual arts, our one mission is the Northern Images mission, which is actually that render is the Northern Images payload. The goal is to have electronic artwork generated by participants in the mission on the ground across the NWT, and we'll display that artwork on a small screen that deploys at the front of the satellite, and then we'll capture an image of that screen with the Earth's horizon in the background. And that will kind of then be beamed back down and becomes our outreach, our visual arts outreach. So a student in art class will be able to create some artwork, and then they get in a year or so a picture of their artwork displayed about 400 kilometers above the Earth. So I think that's quite a nice outcome. And similarly, our language-based outreach will be sort of piggybacking on the comms hardware that will already be on board the bus, but we'll have scheduled transmissions for both creating a sort of global game, as well as sending out messages to amateur radio operators around Canada so that they can hear pre-recorded messages gathered again by students or participants in the NWC.
Wow. So delight for your eyes and ears from space. Sounds pretty cool. I'll hop back to the mainland, and Paula, why don't you tell us what you're up to over at McMaster?
Yeah, hi. So McMaster Nudos, our entire payload. So our CubeSat is also a 2U, and the payload on board is actually a scientific radiation detector. And it's this novel technology that when a radiation particle kind of hits the detector, we can differentiate if it's charged or neutral based on some basic properties of how charged and neutral particles interact with matter differently. And it's novel because a lot of the time radiation detectors don't, in kind of one, are able to differentiate between both. So that's really cool. And it's also really interesting when you think about like long-term space travel, because space, is, we can all kind of imagine, is a pretty harsh environment. And so when we have humans in space, especially like astronauts on board the ISS, and as we move towards Lunar Gateway, going back to the moon and potentially beyond, we really need to be able to measure the radiation doses that astronauts will get. So this science and the novel detector and the novel detector technology will hopefully be kind of help us in our knowledge moving forward with humans in space. And McMaster Nudos is largely comprised actually of undergraduate students. And we do have some alumni, some master's and PhD students helping out. And yeah, we actually have a fair bit of members, around 80 to 100 members, mainly all undergraduate, and just helping out on the different teams, gaining interest in space and helping gain experience in the space industry, hopefully for postgraduate things.
Wow. So if you're measuring radiation in space, do you have to take special care to make your satellite radiation proof or anything? Or how do you get that measurement really accurate?
Well, so the radiation proof, like any satellite needs to be radiation proof so it doesn't damage your hardware. But the radiation detector is really just knowing the very specific materials that you put in it. So we have like a tissue equivalent plastic. So it acts like tissue. So we know its chemical composition. So we know what it's like and how radiation should interact with it. And then we just kind of do a bunch of measurements based on voltages and things like that. And knowing what radiation, but the radiation's there and it's pretty high energy. So it just kind of interacts and then we get readings.
Awesome. So now that we all know who you guys are, I'm just going to open this one up to the floor and you guys can just kind of like take it. It'd be great if you sort of commented and like built on each other's points. But what do you think that the contribution that CubeSats have to making Canada? You all have such different missions, but all of them are like very valuable, like scientifically, biomedically, or outreach wise. So what do you guys think?
Yeah, I think Canada has an amazing presence in the global space industry. You know, robotics and Earth observation for two examples there. I think CubeSats, you know, with their compressed timelines and low cost, it's like that's kind of their superpower for accelerating innovation and sustainability in space. So, like with the CCP here, I think this is a great opportunity to train the next generation of space professionals in Canada. and increase our capability both at university institutions and as with the government agency as a whole. So I think we have a bright future ahead with CubeSats and space in general in Canada.
You can also consider like the effect, like basically back in the day when space exploration started, the Apollo program and the moon landing was the motivating factor for a lot of the previous generation. Like those people who are or professors or mentors in the industry to actually get involved in aerospace and spacecraft development. And I feel like maybe CubeSats can be considered one of the motivating factors for our generation, because for us to see something in media is not as exciting as it was maybe for our parents, but for us to participate in something small but still real can be a catalyst to actually get involved and move on to doing great things later in the aerospace engineering field.
Yeah, I agree with Lavent and Alex here. The CCP has given like a lot of students, from undergraduate students to high school students, and even graduate students. They've given us a lot of opportunity to actually work on space projects, and that's that's something that you can't really experience anywhere else. And even if like the students don't end up working on space stuff, well, I hope like all the students would, but even then, if the students don't, then they would have that experience of being able to design and build something that that flew into space, and I'm pretty sure that skill can be transferred to any other industry wherever the student may go. And I think also it goes without saying that the CubeSats have tremendous science contributions. For example, for measuring oxygen red lines at very high altitudes, measuring brightness levels of point sources on Earth, or detecting radiation with a novel approach. Like that's a huge contribution to the science. But again, I think more so like this whole project, its contribution mainly is like training like the next generation.
I think to just sort of add a final point to this too, it is also just really inspiring, and for me, I know it's helpful to kind of just, especially with the CCP, to realize something like this is actually going into space, and CubeSats and these projects are realizable, and it's something that you can actually do as an undergrad, as a high school student. You can participate in these projects, and like it's been said, like they're small, they're short timelines. It's really up to your imagination of what you can do with it. So be it science, be it new technologies, engineering, all these things, it presents a whole new domain to do really cool things with, and something that you can do even as an undergrad. And I think that's really, really cool.
And I think it's also important to note here, following up on what Paula said about new technologies and such, is that the Canadian CubeSat project and CubeSats actually give Canadian students an opportunity to test new technologies in space using like a domestic operation, as opposed to having to rely on foreign programs to get their projects and research and experiment into space. And it's also really important that a lot of these experiments, they might be avenues into new technology, good ideas which come up in university, and now there's an opportunity for students to actually get those technologies into space through CubeSats, and that's really great, because some of those projects would potentially never reach their full potential if it wasn't for having this domestic opportunity, or if it wasn't for CubeSats, because at the end of the day, when you're building a CubeSat, you're risking a couple $100,000 or a couple $1 million, as opposed to actually putting some sort of new unproven technology onto a large satellite. Then you are looking at risking tens, if not hundreds of millions of dollars and years of time for turnaround. So CubeSats also provide opportunity for new Canadian technologies tested and tested and developed, which otherwise couldn't be possible.
Mm-hmm.
Yeah,
Hey, that actually, oh, go ahead. Sorry.
Oh, no problem. I wanted to sort of echo that point as well, that I feel like, sort of as mentioned earlier, Canada is so large and we're so distributed that create opportunities like this are creating so many communication pathways to share ideas. And with something like the CCP, a lot of those ideas are actually getting tested with like a real piece of space hardware. And I don't think it's possible to understate how much of a steering effect I think that will have in 5 to 10 years with what the larger satellites are doing. So these smaller tests and sort of the capacity that's being built, sort of from our perspective here, it's really all about capacity building. I think if we get more people introduced to satellite technology and able to realize that they can steer it or have an impact on it, I think it's really meaningful. And yeah, in 5 to 10 years, what that can be is I'm very optimistic for the possibilities in that area.
Mm-hmm. It sounds like you're all part of this great positive feedback loop where you're creating this capacity and you're training all these new people, and then that is creating the possibility to kind of like test and build new technology that can actually contribute, which is really exciting. I think as like from high school students all the way to graduate students, it's very cool to see how you guys are kind of contributing to Canada's space sector. We do have our first question from YouTube. It is for Paula. This person is wondering if your detector is designed in-house by your team.
Yeah, so it's a great question. And it is actually, it's a completely new detector method, and it was designed by one of the professors here at McMaster alongside a bunch of his students, either PhD, masters, some undergrad contributions there too. So yeah, it's all the design, and it's actually being built in-house too.
So once again, we really are seeing like how you guys get to work on really relevant technology and also build a lot of that that training capacity. Okay, so moving on kind of more to the technical side of your satellites, or just satellites in general. You're not married to your own for this question because you guys are kind of experts as you've been working on them. But how do you think that satellites improve life?
Yeah, I can go ahead. I think there's a lot of ways they can improve life. And I mean, there's more obvious ones, you know, like look at when you're trying to find the place you're going and you pull out your phone and it's almost, we take it for granted. So that's an amazing part of it. And I think even better than that is, you know, how satellites have enabled global communication at high speeds, and our access to information and knowledge these days is just incredible, and it's changing the world. Some may say for worse, but I think for better in the long run. And looking at more kind of down to earth implications, I'd say, you know, for natural catastrophe preparation and mitigation, I think that's incredibly important, as well as looking at, you know, water levels and ice levels around the planet, keeping a monitor on, you know, how climate change is really affecting the planet. And finally, you know, monitoring a dangerous species, be it pods of whales or animals in Africa, that's also very important to do, and satellites give us that capability.
Yeah. Oh, sorry, go ahead.
I was just going to say, following up on that, I think satellites are also really important for global security. If you know what your opponent and another military power does, and their operations are transparent to you to some extent, then it's more likely that you will be able to hold each other accountable and avoid conflicts which could get out of hand. I just wanted to add as a follow-up to Alex's comments.
Yeah, sure. Because I was gonna just add on to what Alex said over there. One of the obvious benefits that satellites give is like when they take imagery of the Earth. Now there's a lot of knowledge that you can get from that. In fact, one of the students who worked on our CubeSat 2 now, when she graduated, she's now working for for a company that has like a bunch of satellites orbiting the Earth, and they take imagery like of the Earth, like a lot. They take a lot of images of the Earth, and from those images, like for example, you can get data for like climate change data. You can get data for like what, I guess, over the history of however many years, how did this affect that, and you know, from there. From space, it can actually affect decisions that are being done on the ground. And so, yeah, that's one big thing the satellites contribute.
Yeah, I'd really like to bring up, I mean, a few things that maybe are really regionally specific to the NWT, but I think are great examples of how satellite technology is being used. The first is that a large majority of the research we perform in the NWT, or my colleagues perform, is really dependent on satellites for remote links. So we'd be running things like remote permafrost monitoring installations or meteorological towers that are all, some of them are hundreds of kilometers away from the nearest sort of developed infrastructure. And so they're all relying on sort of kilobytes a day of data generation, but still really important for building that understanding of this great piece of rock that we're on, and trying to understand that better. And secondly, the schools here, again, because they're quite distributed, the flying communities actually use a dedicated satellite link to the school. So all of the material that the students are accessing through, say, Moodle or another learning platform like that, just can't be delivered through the normal sort of what is equivalent of perhaps a 56K internet connection. That is really limiting for some of the communities north of us, like say Sax Harbor, Ulahaktak. So having that satellite link is a game changer in a way for being able to promote sort of distance learning. So for instance, quite a big success story here recently was that students from Ulahaktak straight out of high school into university, and that's usually kind of unheard of because you have to travel to get education. But for the first time, those students could stay in Ulahaktak and receive distance learning, and that's all thanks to a satellite communication link, which I think is really important.
That's really awesome. I didn't know that. That's quite cool. And I think to go just a tad bit more abstract than kind of a lot of the examples mentioned, is that one of my favorite things about space and the question that I feel like a lot of people who are into space kind of get is like, well, like we have so many problems on Earth. Like what's the point of kind of going out there and doing stuff? And my favorite answer is that the body of human knowledge and the way that we learn isn't linear. So like a lot of what we do for science, for space, for the pursuit of knowledge has so many real world implications later on that we just can't maybe see right now, but are inevitable. So for an example with satellites, like a bunch of scientists wanted to study the sun because that's what they're interested in. The sun, it's right there. It's a big fiery ball. Let's learn more about it and let's increase our knowledge of science and space. But that has a whole lot of real world implication with, you know, activities of the sun potentially harming Earth and increasing our radiation and things like that. So, or even with the example of satellite imagery, recently they actually were able to discover new archaeological sites in places very randomly remote from satellite imagery that was used for wildly different purposes, but somebody else in some other discipline is looking at that information and has a new perspective on it. And so I think that's one of the biggest ways that satellites and space technology and science in general really benefits us, is that even if we might not see the direct implications, it kind of inevitably will sooner or later impact our daily lives and just the way that we learn and gain knowledge about the universe around us.
I really am happy, Paula, that you took it in sort of like a bit more of a philosophical direction, because I wanted to ask you guys, like, you know, AuroraSat, so Patrick and Alexis, you guys both kind of have satellites that are focused on outreach and inspiration. And I wanted to hear your thoughts about like, do you think that satellites or just space flight or space work in general is important for inspiring the population?
Yeah, like of course, like so for example, for Rorasat, for Patrick's team, and for what they're doing, like that's big in the outreach side of things, in that, you know, like training high school students, like with this project. Like I don't even know what I was doing in high school. Like I'm 100% jealous of these high school kids. Like I wish I was like part of a CubeSat project when I was in high school. And so, you know, like who knows like what these high school students could do like in the future, now that they're trained in this kinds of projects, right? And so it's amazing to see that, really. And so for our CubeSat too, it makes space more, I guess, approachable to a lot more people, because, you know, like space can be scary. Like a lot of people wouldn't even, you know, like think about making things that go to space. And so being able to have, you know, like that product of a CubeSat, you know, that's something from space, and bring that back down to them, and they can relate to it. They can easily see, you know, like what it's like being in space. I think, you know, that would inspire them to you know, approach space more and be more open to what space technologies can do to them and for them.
I have to agree that I wish there was something like this happening when I was in high school. That's a very good point in terms of, yeah, what kind of opportunities are coming out of projects like this. It's sometimes hard to pinpoint exactly. They're sometimes hard to measure. And I would like to, or I suppose how I think of it is that sometimes space stays very abstract, and it is hard to measure or sort of make tangible. And I think this is a huge step in that direction. Sort of the CCP in general, or all of these initiatives, anything STEM education related, and a lot of the stuff SEDS do is all making it tangible. I think that's really important. And even just down to like the scale of the satellites that we're all building are incredibly tangible. Like you can pick it up and hold the model. Everything is so tailored to getting that exposure. It's sort of, yeah, really positive in that light. And even thinking, so in Inuvik here where I am, we have the Inuvik satellite station facility. So it's quite a big installation. It's the first thing you see when you drive into town. And it's nice to now have projects like this that really can link to that already existing infrastructure, and hopefully provide people with an understanding, or at least an exposure to what that infrastructure is here for. Like, what are the different things it's doing? It's not abstract anymore or scary. It's sort of on your table, and that can be a little model of a CubeSat pretty easily.
I have to agree with Patrick too. I think like outreach is really important, and every minute what you spend talking to somebody younger or less experienced, it's a minute well spent. Because if you just think about it, one day, like if you just spend one day with outreach every semester, how much work could you get done for your own satellite in a day's time? Even if you work really hard, you're not going to be getting that much stuff done on the scale of a satellite project, which is a multi-year enterprise. But if you have just spent interesting day with a group of high school students who all got an interest in this one level or another, and eventually maybe even just a small percent of them ends up pursuing a career in STEM or aerospace engineering, then your impact through that is very difficult to quantify. It's huge, right? Like it's it's very, very important that we do this while we work on the satellites, and it's just as important for the CCP to do this than to actually build something which will go to space.
Mm-hmm. Okay. So what's next for your guys' team and the CCP? I'll walk you guys through this one because this is definitely directed at all of you. So Alex, why don't you start us off?
Yeah, so I mean, next steps for our team is to just make sure we're paying attention to all the requirements and, you know, doing what we have to do to get Violet's in low Earth orbit in about 2 years from now. So it's going to be just as fun process as it has been, and just as stressful. But you know, I know I'm like incredibly excited to see that rocket launch, and I definitely plan on going. And I think hopefully after Violet and CCP1, hopefully there's a second CCP, and then we can get the next generation of students going through the pipeline.
I love that answer. You know, what's next for your team in the CCP? The next CCP. So that's really great to see your commitment. You mentioned that it's like very fun, but also very stressful. What would you say has been like the biggest challenge for your team so far?
Yeah, I think the biggest challenge, and I feel like most of the other CCP teams who have universities that haven't touched spaceflight hardware before can agree with this too. Finding personnel can be challenging. You know, there's schools like Concordia and you know, UBC. I believe UBC. You know, they've had pre-existing programs, but they have kind of a ecosystem, a space culture there that didn't exist at UNB prior to the CCP. So. That's been a big challenge recruiting people, but you know, the people we do have are incredibly passionate and motivated. It just means we have a little extra on our plate, but it's nothing we can't handle.
Well, considering that you guys are like kind of breaking ground in this way, it sounds like CCP2 or CCP3, CCP100 will all be much better equipped to like really succeed out of UNB. So it's awesome to see you guys kind of breaking ground there. Paula, what about you over at McMaster?
Yeah, so similar next steps in that I know for McMaster Nudos, it was actually the idea to build this CubeSat happened a decent time before the CSA announced their CCP project. So a lot of our designs have been a long time coming, and we've spent a lot of time on our designs. So moving into the next phase of this project and actually getting the physical stuff and starting to test it is a major next step, along with a lot of software development. Yeah, so that's really exciting to actually sort of begin to realize a lot of our hardware designs and start playing with them in the labs. Yeah.
Awesome. And apparently one of our viewers on YouTube liked Alex's answer to the challenge question, and now they are wondering what the biggest challenge has been in your experience.
So I think it's a pretty similar answer. Space can be pretty niche. And while a lot of the things you learn in classes do transfer over, especially in a lot of the engineering disciplines and sort of best practices and stuff like that, once you get down to the nitty gritty, it is rather specialized and niche, and getting that kind of personnel and building up the body of knowledge, not just in a select few people, but because a lot of this is with universities and there's a lot of turnover in people, having that knowledge transfer of sort of very specific niche topics can be a little difficult, but we've been doing it for a little while now, so we've got a little bit of a system going, but it's definitely a big challenge.
I see. Okay, Patrick, what's up for you guys?
I think for us, it's sort of been the theme throughout this whole thing is just to keep learning as much as we can as we move forward. So yeah, I'm assuming as several other teams, first time developers of anything space related. So really concentrating on keeping learning and getting in touch with the right people and using the resources that are out there. There's lots of passionate people who are very keen about anything science related and outreach and just building capacity in general. And so there's so much going on that front, and I think that's really where we're going to concentrate to keep things rolling, and sort of, and as mentioned too, trying to document that and keep it alive so that when CCP2 comes around, we're already walking, if not running, in the right direction.
sounds great. Lavent, what about you?
Okay, yeah. So the next step is just to finish up actually building and testing the satellite. We have spent a lot of time up to this point on the design and reviewing the design to make sure that what we are planning to build is going to meet the requirements. The next step is to actually build the things. That's what we are in the middle of right now, and then do another review to see whether what we have built is actually meeting the requirements. And then after that, we will be preparing for the launch, and also just making sure that all the permits and regulations are followed, and we have all the licenses in place to actually get the satellite into orbit. So yeah, those are our next steps, as well as if there would be a second or third round of CCP coming, then we will be looking at participating in that as well. And yeah, in terms of challenges, I would say that for us the biggest challenge has been member retention, just because member retention and knowledge transfer. So we have been, I don't know, I have been on this project personally since the summer of 2018, and not everybody is prepared to spend 2 or 3 years working on this and putting in a consistent effort. So students join and they stay for a certain amount of time. Maybe they will do masters, or they will do a capstone project, and then a select few will remain as the core of the team. But it is definitely sometimes challenging to not see an immediate return on your investment. And I'm just saying that in terms of the design, because now things are a lot better when we are building hardware, testing it, the end result of your work is actually tangible. You can touch the boards, you can program them, you can put them together. But earlier, when we were doing a lot more design, it was definitely challenging sometimes to motivate people for long-term involvement.
Mm-hmm. Yeah, building a CubeSat definitely sounds like an exercise in delayed gratification. So it's great to see all you guys and your teams kind of pushing through. So that brings us to, last but not least, Alexis. What's next for you and your team?
Sure. Actually, if you don't mind, I'm going to go reverse, answering your questions. So building off of what everyone else said about the challenges for this project. Yeah. So this is also Western's first CubeSat ever, and I guess first ever space project. And so finding the people who would, who would be interested in doing it. It's easy finding people who are interested. It's difficult finding people who are, skilled or have experience in these things. And so that's definitely one big problem. And also, as Lavent said, the knowledge transfer across multiple years is also difficult because, 1 year capstone, and after the students complete their final report, they're just done. They forget about it. And obviously, the next set of students, reading documentation is hard. And so that's a huge challenge of all right, so this is what they have done. This is what you guys need to do next. And so all of that knowledge transfer stuff, it is very difficult. And so what's next for our team is the hope that we would continue to adjust to that challenge, in that we can, train more students in a better way than what we have done before, in the hopes that when they leave the project eventually, or when they graduate, they'd be set up with the skills learned from this project. And in fact, one of the students who graduated also from this program is now working in a European Space Agency. So I think that's a testament for how well the CCP overall, and I guess Western's team in general, how well we've transferred knowledge and I guess trained students in this kind of realm. And so aside from all the programmatics and the CDR and the flight readiness review and all of that, so what's next for our team is just continuing to train students and hoping for the best learning outcome for everyone.
Mm-hmm. That actually segues really well into a question that has also come from YouTube. So you're talking a lot about like how hard it is to find dedicated students. Do you just look in engineering or science for your students, or are they multidisciplinary?
Mostly it's engineering and science students because like building a CubeSat is mainly an engineering problem. Although like we are not limiting like all like who would want to apply for it to be just from those fields. So for example, our orbit team is composed of students from the geology department. So obviously that's, like very far apart, but they were very interested in working on CubeSats and stuff. So they worked on the orbit side of things. And so definitely it's not limited to just, like engineering, like electrical and computer engineers. Like there's a big science side to it too.
What about the other teams? Do you guys have like big representation outside of science or engineering?
I would say that for the orchestra team, we have some. We definitely don't limit the involvement from other faculties if they choose to reach out to us, or if we somehow integrate them into the team. We do have some business students helping with marketing and the financial aspects of the project, and but it is mostly physics and engineering, just because of some of the hard technical skills and the general background what you need to actually get involved in the technical tasks. So yeah, we usually do recruitment every semester, where we reach out to the various STEM like faculties which belong to STEM, and then people need to complete an introductory project, and just to show that they are dedicated and they are just and this is like above a passing interest. And then once they complete the intro project, then we integrate them into the various teams and get them started with technical work. So yes, mostly I would say electrical engineering, software engineering, physics, those are the and mechanical engineering as well. Those are the most common disciplines you would find.
Mm-hmm. Okay, awesome. So we'll just go with a one-word answer to this one. Are you guys all excited for launch? We're getting a lot
Absolutely.
I said one word and then everyone went to gestures. Yeah. Is there anything that you are worried about for a launch? I guess, you want the rocket to fly, but is there anything else? Is it like, do you feel anxious about it, or is it just pure excitement?
I mean, I think like time scales, and you're putting something into space, and once it's up there, there's not a whole lot you can do if things start to go wrong. Obviously, you do your best to mitigate and kind of plan and think about all the things that can go wrong. But space can be a pretty harsh environment. So I think from my part, I know there's a lot of excitement. It definitely outweighs all the stress and maybe fear. But there's still a little bit of that.
A bit of fear, yeah. Yeah. Okay. Lots of nods. Lots of agreement on that one. All right. Another restriction to one word. I'll go across my screen. So, Alex, how would you describe your experience working with the CCP?
Fun.
Alexis?
Or hard.
Fine or hard?
I was going to say exciting. Yeah.
Okay. Paula?
Uplifting.
Uplifting. Patrick?
I would say strengthening, if I could choose one.
Okay. And then Lavent?
I would say rewarding.
Rewarding. Okay. These are all really positive words. So I think the CCP is definitely doing its job. Okay. I think that actually is the end of the presentation and the kind of questions that I had. So I will just thank everyone for your time. It was really great to get to know like a bit more about all of your teams. And it was so great to have such like broad representation from across Canada. It's really nice to see how the CCP is kind of bringing everyone together in like the common challenges of kind of training a team, but also the excitement for the launch. So thank you guys all so much.
Thank you for hosting this. It was a lot of fun.
Thank you, Katie.
Yeah, no problem.
Yeah,
Also,
super.
okay. And I also just wanted, for all the viewers out there, a kind of silent person in this this sort of situation has been Alina, who has been managing all the Zoom stuff and also getting all the questions from YouTube onto our Zoom. So thank you to Alina for doing all the work. And if you are interested in more fun World Space Week stuff from SEDS, there will be a takeover tomorrow on our social medias, and then we're doing a fireside chat on Friday. So stay tuned for more space-related content.
This week.
Have a good evening, guys.
See ya.
Thank you.
Have
Bye.
a good evening. Thanks.